We want our answer to only have miles. That's what we want. Okay. So what do? Well, what we can do is flip or invert this rate to get this. Okay, we can invert that or flip it. As you can see, some people also call this taking the reciprocal. And now we multiply. And now the units cancel, right? Miles is on top. Miles here is in the denominator. So they are going to cancel. Right? We want our answer to be only gallons. The unit, to be only gallons. So we have this. So as you can see, we have this. I mean, probably I should have put the over 1 when I was typing up the notes, but hopefully everyone can still understand. And again, what happens here, we get we have 1 over 15 gallon times 30. So the 1 over 15 times 30, I can bring that in front of the unit gallons. Okay, I know here it's gallon, here it's gallons, but that's okay. So we have 1 over 15 times 30, which is the same as, if you just multiply, you get 2. So we get 2 gallons here. Again, the whole point is you want to do this product. You can bring the numbers in front of the units. That's all I'm doing here. So we have this. And we get 2 gallons. All right. So that's for that question. Are there any questions on this? Or let me ask it this way, excuse me. What questions do you have? And if you have none, that's fine. I just want to make sure everyone is learning this.
Can we do a different example than the ones that we did yesterday for rates?
I have not prepared those. I really want to do the same ones from yesterday because I felt like yesterday I didn't explain them as well. So.
Okay.
Okay. We'll see other examples though. Okay. So let's do this. Let's do this one. So let's say again, we want to be, so let's say we're walking now at a rate of 1.5 miles per hour. Now we have 2 questions here. How far can I walk if I'm going to walk for 4 hours without stopping? That's the first question, okay? So let me say it again. We're walking at a rate of 1.5 miles per hour, okay? And we want to know how many miles can we walk if we're going to walk for 4 hours nonstop, assuming, of course, we're walking at this rate, which is what we're assuming. Well, again, let's use rates. We can make a rate, so we have 1.5 miles per hour right? 1.5 miles per hour. So we made our fraction. That's our rate. Now, if we're walking for 4 hours, again, we want our unit to be in terms of miles, right? We want to know how far can I walk? How many miles can I walk? So we want to eliminate the hour unit. Well, if we were to multiply by 4, like so, we have that cancellation. So by multiplying, our answer will be 1.5 miles times 4. And the 4 you could just bring in front over here, and you get 6 miles. And this is good because, again, we want our answer, the unit, to be only miles. But the hours unit canceled. That's what we wanted. So we just multiply. That's all. Okay. That's for 1. Now for number 2, Okay? Let's try that one. We want to know how long it would take to walk 9 miles, right? How long it would take. Well, again, if we make the same mistake where we just multiply this by 9 miles, right? We want the miles unit to essentially go away, right? Because we want our answer to be in terms of hours. How long would it take? How many hours? Well, if we just multiply by 9 miles, you can see there's not going to be cancellation. It's just like last time. It's just like the previous example, right? You have miles on top. You also have miles on top. But when you multiply them, they're not going to cancel. You're going to be multiplying miles with itself. You get miles squared. The hour in the denominator, that's still there. And of course, this doesn't make sense. There's no cancellation. We need some cancellation to occur. So what do? We're going to invert it. So let's try flipping the rate, like so. Then if we multiply by 9 miles, then there's cancellation. As you can see, right? Miles is on top, miles is on the bottom. I could put this over 1 because it's just a number. You know, an integer, any number, is the same as the number over 1. Miles cancels. We're left with hours, right? We have 1 over 1.5 times 9, which is 9 over 1.5, and that's the same as 6. So it'll take us 6 hours. So that's using the factor label method. It's just, again, multiplying, but you just want to make sure the right unit cancels, right? Again, we want to know how long, how many hours it takes us, right? So we want miles, that unit, to go away. Okay, that's great. Now, what questions do you have on this? Okay. Well, now I'm going to show you another way to do it. Basically, we're going to use proportions. Remember, rates are ratios. And to say two ratios are equal, writing this, that's just equivalent to cross multiplying. In other words, this will be true if and only if this is true. If you can cross multiply and preserve that equality. So this holds, this equality is a true statement exactly when this is. Now, since rates are ratios, right? Since rates are ratios, we can use a proportion to solve them. And we can also do unit conversions with them. I mean, if you look, the way we did it, we dealt with a conversion factor or a unit conversion, but those are also just ratios. So we can still use proportions to solve them. Basically, what's going to happen is this, what I wrote here. You're essentially going to make two ratios. One is going to be from the given information, kind of like what we did here. We get a ratio using the given information. There'll be another ratio with an unknown, and then you'll solve it using this. We'll solve it using this. What you do have to be careful about is you need the units to be, you have to be consistent. In other words, units have to be in the same corresponding spots, as you'll see in the examples. You want units to be in the same corresponding spots. So let's say, for instance, we can drive 25 miles per hour. The question is, how far can we drive if we drive for 5 hours? Now, how can we solve this? Well, notice we do have a rate that's actually given to us, right? 25 miles per hour. Miles per hour. See? Miles per hour. Okay. Now, what about the other rate? Well, we want to know how far we can travel if we drive for 5 hours. So what I'm going to do is this. I'm going to write let x be how far we can drive if we're driving for 5 hours. That's our unknown. How far we can drive if we drive for 5 hours. Okay. So again, to make this more mathematical, I'm using a variable. So I'm going to call it x to be that unknown distance. And then we can make another rate, another ratio. How far we drive if we're traveling for 5 hours divided by 5 hours. So this is another ratio. So again, this ratio, this rate was based on the given information. This is a rate that has an unknown, which is what we're looking for, the distance we travel if we drive for 5 hours over 5 hours. And then we set them equal to each other. They're actually equal because they both deal with how fast we're driving, miles per hour. But notice the units are in the same corresponding spots. In the numerators, you have miles. The denominator, you have hours. And what you can do is this, right? You can cancel units. So you cancel and you get the ratio, the proportion here, cross multiply. So you have 25 times 5 equals x times 1. So x is 125 miles. So what questions do you have about this one? I hope this makes sense. You're basically finding two ratios, you set them equal to each other and just cross multiply. That's really in the end what it boils down to. On an exam or whatever, you don't have to write let x be the distance and all that stuff. But it should be obvious from your notation that x is what you're looking for.